parameter nonlinear system, and it was dx dt equal x squared minus a, dy dt equal minus y x squared minus y. So here the parameter is little a, so we're going to say it's polynomial versus little a. So the first question was find the equilibrium point versus a. So we need to have, so this is about equilibrium point. So we have dx dt equals 0 and dy dt equal 0. So if you look at the second equation, the first equation will give us x squared equal a, while the second equation will give us minus y times x squared plus 1 equals 0. Clearly, x squared plus 1 will never be equal to 0. Therefore, we have x squared equal a, y equals 0, or minus y equals 0. So the whole discussion should focus on a. If a is positive, then we have solutions. So here let me write now the conclusion because of the first one. So if a is positive, then we have two solutions. X equals plus minus square root of a, so we have square root of a 0 and minus square root of a 0. These are your two equilibrium points. If a is equal to 0, we have only one equilibrium point, 0, 0. And finally, if a is negative, we have no equilibrium point. So we see here that we have a kind of bifurcation when a is equal to 0. So the second question deals with to look at this equilibrium point and classify them as sourcing, saddle, and using the nullclines technique. Okay, so for that, let's look at case by case. So we start first. So this is the nullcline technique, the nullclines technique. So here we go. We're gonna draw the nullclines case by case. So if we start with a negative, so in this case, we see that dx dt is never equal to 0, and dy dt equals 0. So here we see that x prime equal x squared minus a is never equal to 0, so there are no x nullclines, while y prime equals 0 gives only y equals 0 as we saw before. So we do have the y nullclines, so the y nullclines, but no x nullclines. So we draw the solutions. So let's draw the nullclines in blue, okay? And we know that the one nullclines we have either left or right. So here we draw it, so that's y equals 0, that's the x-axis. We do have only one equilibrium, we have no equilibrium point, sorry, and we need to find now the arrows along this one, and we will find that it goes always left. So, I'm sorry, right, dx dt is equal to x squared minus a, which is always positive. So here it's going to be right. So the arrows are like this. So the solutions are behaving like this and like this. Okay? When a is equal to 0, so in this case, the x nullcline is x equals 0, and the y nullclines are equal to 0. So again, the blue one is going to be the x-axis, but this time the red one will be up or down the x nullcline. So we go here and we draw it, and we draw the So the red one is the y-axis, while the blue one gives me the x-axis, y equals 0. So the arrows are again going right on this one, and on the x nullclines we have down here, up here, and we do have one equilibrium point, which is 0, 0. Okay, it's not very hard to see that there are solutions living on the x-axis, okay, and we have solutions living on the y-axis. So if you remember the beginning of chapter 2, we can take x equals 0 and the system will be satisfied. Of course, I'm assuming that a is equal to 0, so a equals 0, so the system is dx dt equal x squared, dy dt equal minus y times x squared plus 1. So if you take x equals 0, the first equation is satisfied, there are solutions living on the y-axis, and if you take y equals 0, the second equation is well satisfied, so there are solutions living on the x-axis. This is very important because this tells you that the solutions, like for example, if you have a solution here, okay, then the solution will be coming down, okay, right, while this one here, the solution will be going up, right, and here solutions will be going up, right, and here solutions will be going down, right. So as you can see, the 0, 0 is attractive from the left, but it's repelling from the right. We have like a saddle basically, okay. So the last case is when a is positive. So in this case, x squared minus a equals 0 for the x nullclines gives me x equals square root of a, or x equal minus square root of a. And in this case, you have two vertical lines with up and down arrows, okay? And for the y nullclines, you get, again, y equals 0, and with left or right arrows. So if we go to draw the nullclines, so we get we draw first the y nullcline, that's y equals 0, and then we go to the x nullclines. They are symmetric vertical lines, and then we put the arrows, okay, so they will be down here, up here, on this one is always going, I mean, it's right here, left here, right here, and we do have two equilibrium points. So now the solutions behave like this. If you have a condition here, solutions like this, and here they're coming, here solution like this, here solution like this, here solution go like, and solutions. There are solutions living on the y-axis, and there are solutions living on the two vertical lines, x equals square root of a and x equal minus square root of a, okay? Because it's very easy to check that the first equation in your system is satisfied. So this minus square root of a 0 behaves like a sink, while the square root of a 0 behaves like a source. So this behaves like a source, while this one behaves like a sink. If you go back, the last question was what happened when a is equal to 0. So as we said, the 0, 0 behave like a saddle, and with the help of the nullclines, we are able to draw the behavior of solutions.